Let us see about the switching characteristics of SCR. What is switching characteristics? When you turn on or turn off the device, there will be a difference in the voltage and the current waveform across this device. That is called the switching characteristics. The switching time includes both turn on time as well as turn off time. So when will a device will get switched on? So first SCR should be forward biased and we have to apply the gate current so that device will get turned on. So let us see what happens to the voltage and the current waveform when we apply the gate pulse. The turn on time of SCR is the time required to change from forward blocking mode to forward conduction mode. Actually, it consists of three components: delay time, rise time and spread time. So these things we will discuss later. So if we give a more gate current, it will turn on quickly, and this magnitude of the current should be at least 3 to 5 times greater than the minimum gate current specified by the manufacturer. So the total turn on time depends upon three factors. What is the magnitude of the gate current? What is the shape of the gate signal and the circuit in which SCR is connected. So now we can see the characteristics during turn off. So turn off time is the time required to change from forward conduction mode to forward blocking mode. This turn off process will be initiated by reducing the anode current below the holding current, and SCR should be reverse biased for a finite period so that SCR will regain the forward blocking capability. So the process of turning off of SCR is called commutation. This is more important topic, this commutation. So this is the switching characteristics of SCR. This is the on time characteristics. So on time is given by delay time, rise time and spread time. So this is the voltage across the device and this is the current waveform across the device. So let us see the current waveform first. So initially SCR is in off condition. So before this line, okay. So when it is in off condition, current is 0 or leakage current is there, and voltage is some voltage VA is there across the device. Now when you apply the gate signal, what happens? The current starts to rise. So it rises from leakage current to 0.1 of this final current. So that period is called the delay period. And after that, from this 0.1 IA, it increases to 0.9 IA. This period is called the rise time of SCR. So rise time, it increases from 10% to 90% of this current. And this is the spread time during which it increases from 0.9 to the final value IA. So total turn on time is a combination of TD plus TR plus TP. So after that it reaches the steady state value. So during this period you can see the voltage waveform. So at the same time voltage starts to decrease from VA to 0.9 VA. Then during TR it changes from 0.9 VA to 0.1 VA, and during spread time 0.1 VA to forward voltage drop. So this is the voltage waveform and this is the current waveform during the turn on period. So now we can see the turn off characteristics also. So here you are switching off the device and the current starts to decrease. It goes in reverse direction for some time, reaches a peak value and then decays to 0. So this total time is called the turn off time, or TQ is the turn off time of the SCR. So it actually consists of two currents or two time periods, TRR, that is the reverse recovery time, plus gate recovery time. So this recovery time is required to remove the charge carriers in the junction. So SCR has PN, 4-layer device. So 3 junctions will be there. You have to remove the charges stored in the junction. So at the same time, if you see the voltage waveform, it also goes in reverse direction for some time, and when the current reaches 0, it will also cross 0. So that after this period only, it will regain its forward blocking capability. And this pink color dotted line is called the circuit turn off period. This TC is called circuit turn off period. So we will see about this in next slide. Always this TC should be greater than the turn off time of the SCR. Okay. This is summary of the turn on time we have seen in the waveform. So this is the switching characteristics of SCR. So during reverse recovery time, charge carriers in outer junctions will be removed, and the charge carriers in junction J2 will be removed during the gate recovery time. So this turn off time depends upon magnitude of the forward current, rate of change of current at the time of commutation, and the junction temperature. So circuit turn off time. So this SCR is a part of this power circuit. Suppose I want to turn off this SCR and making the anode current fall below the holding current, and SCR is about to turn off. Now due to this circuit, some current is flowing here. So in that case, SCR will not get turned off. Instead it turns on again. So this is called commutation failure. So to avoid this, you have to ensure that in this circuit also current will not flow through this SCR, or it will provide necessary time for the SCR to regain its forward blocking capability. So that is called circuit turn off time. So TC should always be greater than TQ so that commutation failure will not occur. So there are two types of SCR. One is called the converter grade SCR. So in this case, the turn off time is 50 to 100 microseconds. So this SCR is cheaper. It is especially used in control rectifiers and AC voltage controllers. There is another type called inverter grade SCR. Here the turn off time is 3 to 50 microseconds. Actually it is faster, so it is expensive, and it is used in most of the DC circuits like chopper and inverters. So what you can remember is SCR is switched on when SCR is forward biased and positive voltage is supplied between gate and cathode. For switching off, anode current should fall below holding current, and SCR should be reverse biased for finite period. So higher magnitude current means lesser will be the time to turn on the device, and gate current should be greater than 3 to 5 times the minimum gate current. During rise time, losses will be more, and this process of turning off of a SCR is called commutation, and circuit turn off time should be greater than the thyristor turn off time for. So these are some of the questions related to this topic. So if you want the answers, you can find the link in the description. And if you like the video, do subscribe to our Read Electric Vehicle channel. Thank you.